Let's analyze the change of the whole system when the input changes from 0 to 1. We take the parasitic capacitor into consideration. Before analyzing the whole circuit, we draw the structure of the circuit before switching. Before switching, the input is low level. It's open between DNS of the first stage inverter and the output of first stage is high level. Between GNS of the second stage inverter, there is a high level. So between DNS of the second stage, the inverter is R-on. R-on and RL divide the voltage US in the second stage inverter, and RL is far larger than R-on. So the output of the second stage, that is the output of the buffer, is low level, which realizes the function of the buffer. Let's see what will happen after the input change from low level to high level at t equals 0. After the voltage changes from 0 to 5 volts, we suppose this capacitor doesn't affect UI1 changing from 0 to 5. Then UGS1 changes to 5 immediately. It makes a current flow through DNS of the first stage converter. There is a resistor R-on between DNS. Will the change makes a low voltage level between GNS of the second stage inverter, then open DNS of the second stage inverter? Let's see. Because of CGS2, the voltage between GNS cannot change immediately. So we need to analyze the circuit containing these elements. We draw the circuit here. Obviously, it's a first-order circuit. We can use three elements method to analyze it. Firstly, we focus on UGS20+. Before switching between DNS, there is the open circuit. So UGS2 equals US. UGS20+ equals UGS20- equals US. Secondly, let's focus on the steady state of the circuit after switching. UGS2 infinite is the voltage division of R-on. CGS2 is open. So UGS2 infinite equals R-on over RL plus R-on multiply US. Because RL is far larger than R-on, this value approximates to 0. Then we calculate tau of the whole first-order circuit. REQ seen from here to the left is a parallel connection of R-on and RL. So tau equals C multiply R-on parallels to RL. Because RL is far larger than R-on, R-on parallel RL equals R-on. The value of R-on is about tens to hundreds of ohms, so it's a relatively small time constant, and the whole circuit changes fast. By applying three elements method, we get the time domain expression of UGS2, that is UGS2 decays from US to 0 with negative exponent. When UGS2 decays to lower than some value, the DNS of the second MOSFET becomes open circuit. So we can see that with the impact of the parasitic capacitor, When the input changes from low level to high level, the output cannot change from low level to high level immediately. We need to point out in this discussion that we suppose the cycle of the signal T is far greater than tau, which means the whole transient process is over in such a time period.